Sanibona, Ramona. Namhlanje we want to do economics of fit test for specific parametric distributions. Yeah. So, phambilini besenza economics of fit test for like proportions, ratios, etc. Yabo, we're testing ukuthi i-data sinalo that follow a set of given values noma ngithi a set of predetermined values yabo lawo calculate as expected yabo. Okay, so manje we wanna do economics of fit for specific parametric distributions. So my parametric distributions is topic so focus on I3 yabo. We have a binomial distribution. This is from STAT130. We have a Poisson distribution. Nakhona ikhona kwi STAT130 and then a normally distribution. Yabo. We're testing ukuthi i-data sinalo mhlambe can be A, B, C, D, E. Ngabe le data sinalo that we've collected or we have observed ngabe lilandela yini lama distributions lawo. Yabo, we can test for either of them. Yabo. So ngizokwenza a recap on binomial, Poisson in a normal distribution, explaining about how do we recognize how do we see a data sinalo can be a binomial distribution. So for a binomial distribution, we know we have a Bonelli trial. So what's in a Bonelli trial? A Bonelli trial is a trial with two specific outcomes. So the outcomes that it can be success and failure. Success or failure. Or meaning a trial, I'm expecting like when I'm doing something, I'm expecting ukuthi leyo nto izokwenzeka noma ngeke yenzeke. Yabo. Noma ngifunda, ngiyafunda le trial engiyenza ukufunda, it says of a Bonelli trial yabo. Because noma ngifunda, it's either ngizophasa noma ngizofail. Yabo, you can look at it ngaleyo ndlela le. And each Bonelli trial into soyazi ngayo, they are independent of each other. They are independent of each other, and the probabilities for a success and a failure, they are constant. The probability of success P is constant, and the probability of failure Q is also constant. I change. And the Lama Bonelli trials, they are repeated a fixed number of times, which is represented by ON. And then if x, if a random variable leads to x, satisfy wonke lama conditions now, we can comfortably say x follows a binomial distribution with parameters n, which is the number of childs, and p, which is the probability of success. So if for x okay. And then again, into binomial distribution, the binomial distribution has into PMF, a probability mass function. The PMF is to calculate probabilities for each random variable. So if of x, a follow random, if a follow binomial distribution, I can have a probability max function. Probability that x is equal to n, which is our number of childs. Choose x is your random variable, and you want to find the probability. Go with p, probability of success, to the power of x times 1 minus p to the power of n minus x. This is the probability mass function we use to calculate probabilities. And another thing, binomial distribution, it is a discrete distribution. Discrete distribution. Okusho ukuthi wonke lama values lawa x lawa they are from 0, 1, 2 up until n. They are fixed values of n. They are discrete. Probabilities futhi kwi-binomial distribution, we can also find them statistical table. You can also find them in the statistical table, and if you're lucky enough go to school and circle, they allow you to use Excel. You can also use Excel to find the probabilities. And then you get, that was a Poisson distribution. Bese ngizoza that was a binomial. Bese ngizoza Poisson distribution. Poisson distribution is one of my favorites. So Poisson distribution just need to memorize something. If me showing a statement it is a Poisson distribution, ndongabona ngayo ukuthi usebenza nge-Poisson distribution ukuthi we have an average over time. Ukuthi mhlambe, if I can say I run a coffee shop, if I say ukuthi on average 5 people buy a coffee per hour, I have an average over time. Average of 5 is kasami, it is an hour. Or I can say on average a class listed on 40 has 15 students per lecture. So a lecture is 30 and my average is 15 students. Same as the binomial distribution, the Poisson distribution is also discrete. It's also discrete, kushuthi nayo inama values are fixed for x. And the average, noma ngithi mean, average or mean, kwi STAT130 it was represented by mu. Mara kwi STAT140 we have a new notation. We use lambda. For a mean. Mara these two things represents the same thing. And then if x follows wonke lama characteristics we can comfortably say x follows a Poisson distribution with the parameter lambda. And then if x follows, and as you may guess, now Poisson distribution has a PMF yakona. A PMF yakona it's a probability that x is equals to x. This should be capital X. Low. Is equals to e, which is the natural exponent to the power of negative mini times e mean to the power of x divided by x factorial. This is the natural exponent. This is your mean, this is your random variable x, and still is the same x. And as I said, it discretely, meaning x is number values from 0, 1, 2, 3 up until n. And the average here, so our mean should be always greater than 0. The mean here is always greater than 0. For examples of izinto ezingaba my Poisson distribution, if it can be it can be the number of bad checks. Can I just read that out? It can be the number of bad checks presented for daily payments at a bank. The number of bad checks on average yami, and then this it is daily. I can say the number of road accidents per month. So the number of road accidents is my average, and then is it is per month. And another characteristics about Poisson distribution, mean noma ngithi average or expected iyafana ne-variance. Lezi mean iyalingana ne-variance if x follows a Poisson distribution. That's another thing we should consider. Bangakwazi ukudida statements bakunikeze i-variance, and when kuzomele wazi ukuthi i-variance is the same thing as a mean or the average. And njengale Njenge-binomial, i-Poisson distribution also has i-cumulative Poisson distribution tables. Yabo, akhona statistical tables. I wish I could go over them, but due to time, but if I find time, I'll make a video explaining what is how we find more probabilities using a statistical table, knowing it's our cumulative Poisson tables. That is a Poisson distribution. And then Makoya, I find this as the worst distribution. Yindi, there's niggas and there's sitting high. Mara, here's to the normal distribution. So in normal distribution, unlike binomial and Poisson, it is continuous. It is continuous, meaning x can take up any value. X can take up any value, no matter it exists from negative infinity to positive infinity. It is continuous. No matter it is also continuous in any given interval. And then again, they usually say we normal distribution would say no matter it's suspected to this data follows a normal distribution. Nongawazi mina characteristics are called no matter how we see a normal distribution, unlike a Poisson binomial. Marage if x a followisha a normal distribution, since x follows a normal distribution with my parameters a mean, mu, and the variance of sigma squared. And then you get to find probabilities of x table we need to standardize. We need to standardize. Into the standardize ngayo funa ukushintsha lo x lo random variables means uz. So uz is equals to x, which is our random variable, minus the mean divided by a standard deviation. This is how we standardize x to be uz, and then lo z also be sumpega comma tables. Unfortunately, in normal distribution, it has a PMF, but it's very, very complicated, so we just stick to using statistical tables. My statistical tables. We STAT140 table. We STAT140 tables binomially Poisson and normal they give us the area to the right. Unlike ET or chi-square, no F, they give us the area to the I meant Poisson binomially the normal they give us the area to the left. And then la maniga distribution like ET distribution, ET a chi-square distribution, chi-square table namanje amatable amaningi they give us the area to the right. So mara lawa normal binomial long move that is recap 130, they have area to the left of the curve. And something else you should know about normally is symmetric about a mean standard normal distribution. One common normal they are symmetric about their mean. We can find the since a continuous normal distribution, a probability that x is less than or equals to x iyafana ne probability that x is less than or x. We no longer focus go equals to. It's continuous, so we shouldn't worry about it. Unlike we level 2 level discrete, we should worry about equal sign. Equal sign can make a very, very big difference calculations. And that is your recap for Poissoni binomially normal distribution. When doing let's test we have a hypothesis work. Each naughty you say your random variable x follows x follows a specific distribution. And then for your alternative hypothesis, you can see x does not follow a specific distribution. But when I get a specific distribution, it's a test for a Poisson, so x follows a Poisson distribution with a parameter mu noma ngithi mean noma funa ligama lini man, hello lambda yabo, and you have to put a value ka lambda, like let's say mhlambe bathi test ukuthi x follows a Poisson distribution with the mean of 3. For each naught, you can say x follows a Poisson distribution with a mean of 3. Uphume kanje uqedile ngo h naught. Then for your alternative hypothesis, x does not follow a Poisson distribution. Yabo. And that is it. Ngizosanda ukugcina live video and then ngizobe sengenza an example. Yabo.